हेलो बच्चों, वेलकम टू द 5% अकेडमी। आप सब कैसे हो बच्चों? आई होप आप सब अच्छे होंगे। मैं भी एकदम बढ़िया हूँ। टुडे विल स्टार्ट ए न्यू चैप्टर ऑफ एनसीईआरटी क्लास 12th केमिकल कैनेटिक्स। सो बिना किसी देरी के लेट्स स्टार्ट। What is chemical kinetics? Chemical kinetics is the branch of physical chemistry that is concerned with understanding the rates of chemical reactions. That is, how fast the reaction occurs to reach its equilibrium state. It also tells us about the speed of the reaction. मतलब reaction कितनी fast होएगी. ओके okay? इस ये हमें chemical kinetics से पता लगता है. Alright? Why do we need to study chemical kinetics? हमें केमिकल कैनेटिक्स को स्टडी करना इसलिए ज़रूरी है क्योंकि it has a lot of applications in our day-to-day life. For example, pharma companies, role of catalysts in speeding up a reaction, shelf life of eatables. हम जैसे खाना होता है उसमें मतलब वो डिके ना हो जो जल्दी से उसमें कुछ डाल देते हैं। वो क्या चीज़ होती है? वो डिके प्रोसेस को स्लो डाउन कर देती है। वो हमें कैसे पता लगता है? केमिकल कैनेटिक्स को स्टडी करके। ओके उस रिएक्शन की। ऑलराइट, action of enzymes in living organisms and many more application. Okay, now we'll study about what is the rate of a chemical reaction. Okay, rate of a chemical reaction. Rate or speed of a reaction can be defined as the change in concentration एक सेकंड बच्चों, पहले मैं लिख लेता हूँ। So what is the rate of a chemical reaction? Rate or speed कह लो जो मर्जी। Rate of a chemical reaction can be defined as the change in concentration of a reactant or product in unit time. Okay, rate of a reaction होता है change in concentration of a reactant ले लो या फिर change in concentration of product ले लो per time, per unit time. Okay, for example, let's consider this reaction. These are the this is the reactant and this is the product. Reactant changes into product at time t equal to 0. Reactant is R1 concentration and product is P1 concentration. Okay, and at T2, let us consider this t equal to T1. Okay, and this is at time T2. So reactant concentration is now at time T2 is R2 and P2 is the concentration of product at time T2. Okay, therefore delta T is equal to T2 minus T1. Okay, and delta R, which means change in concentration of reactants, is R2 minus R1, and change in concentration of products is delta P is, this symbol denotes the concentration of whatever material is inside this box. Okay, since product is in this box, so it denotes the concentration of products. Okay, and delta is change, so change in concentration of products, which is P2 minus P1. Okay, Now, therefore, rate of disappearance of reactant R is given by R is minus, because reactant is changing into product, so reactant concentration is decreasing, so R1 is greater than R2, so that is why we have put the negative sign. Okay, it denotes that the concentration of the reactant is decreasing. Okay, so minus delta R by delta change in change in time. Okay, as we have to write in unit time. Okay, so we divide by change in time, the concentration of reactants. So this denotes the rate. Okay, as we have seen in the definition of rate of a chemical reaction. Okay, and rate of appearance of P as product is being formed, okay, from reactant. So product concentration is increasing over time. So P1 is less than P2 as concentration is increasing. Okay, so rate of appearance of P is equal to plus, as concentration of P products is increasing, plus delta P by delta T. Okay, now we'll study about average rate of a reaction. Okay, what is average rate of a reaction? Okay, what is average rate of a reaction? Let us consider this reaction. Reactants changes into products. Therefore, average rate of reaction R average is given by minus delta R by delta T. Okay, and R average is also given by plus delta P by delta T. Okay, change in concentration of products per unit time. Okay, that is upon change in time. Okay, this is the average rate of a reaction. All right, this one. इस तरह बच्चों हम एवरेज रेट ऑफ रिएक्शन को लिखते हैं किसी भी केमिकल रिएक्शन के लिए. ओके, now let's make a graph of concentration of reactants versus time and concentration of products versus time. Okay, so yeah, this is बच्चों अजीब सी ड्राइंग के लिए सॉरी. एक सेकेंड. Yeah, एक सेकेंड. So this line and this line. Okay, so since here we'll take concentration of reactants. Okay, and here we'll take time. Okay, एक सेकेंड बच्चों. Yeah, okay, so as time continues, the concentration of reactant is decreasing as the reactants are changing into product, as we have already seen. So the graph will be like this. with respect to time, the concentration of reactants is keeps on decreasing. Okay, so at time t1, concentration of reactant is R1. Okay, and at time t2, concentration of reactants is R2. Okay, and at time t, okay, this is time t. All right, so and this is the initial concentration of reactants. Okay, when the reactant is fully full. Okay, this denotes the initial condition of the reaction. Okay, so this is delta R. Okay, delta R, and this is delta T. Okay, so average rate is given by this line. Okay, this one. So R average equal to rate of concentration of reactants is decreasing over time. So minus, just a second बच्चों, so minus delta R by slope is given by, this is the slope of this graph. Okay, this slope gives us the average rate of the reaction. So R average is equal to minus slope is given by dy by dx. So delta R by delta T. So minus sign denotes the concentration of reactant is decreasing over time. So minus dy is delta R. So delta R by dx, delta T. So delta T. Okay, so all right, just a second बच्चों. And at time t, okay, the let me tell you also about the instantaneous rate of a reaction. At time t, dt, let us consider small time interval dt. Okay, let us first draw a tangent at time t. Just a second बच्चों. Yeah, at time t, this is the tangent, and this is, let us consider this small time dt. Okay, and so this will be dr. Okay, dr. So this slope gives us the instantaneous rate. R instantaneous. Instantaneous rate is the rate of a chemical reaction at a particular instant of time. Okay, so R average gives us the rate of reaction over a time interval. Okay, and R instantaneous gives us the rate of a chemical reaction at a particular instant of time. Okay, so R instantaneous is this slope, is given by this slope. Since the concentration of reactant is decreasing over time, so minus dy by dx, so minus dr by dt. This is negative of slope of this graph of concentration of reactants versus time. Okay, all right, now let us draw the graph of concentration of products versus time also. Concentration of products, and here we'll take time. Okay, so as the concentration of products is increasing over time, so as the time passes by, the concentration of products will increase. So the graph goes like this. Okay, So this will be, just a second बच्चों, yeah, this will be T1. Okay, here the concentration of products will be P1, and this at time T2 the concentration of products will be P2, and at time T we'll consider later the small time interval. Okay, first let's consider this. So our average rate of reaction is given by this secant. Okay, so R average is equal to, as concentration of products is increasing over time, so plus sign will come, so delta plus delta P by delta T. So P2 minus P1 upon T2 minus T1. Okay, now see, this is delta T and this is delta P. Okay, now at time T, just a second बच्चों, now at time T this will come in concert boxes. Okay, as these denotes concentration. Okay, now at time T let us draw a tangent first at this curve at time T. Okay, this is the tangent. So at time T ये तो dt हो गया, ये स्मॉल टाइम इंटरवल. ओके, एक सेकेंड बच्चों, या ये टाइम इंटरवल हो गया dt टाइम इंटरवल, स्मॉल टाइम इंटरवल. ओके, इन्फिनिटली स्मॉल टाइम इंटरवल, एंड ये हो गया dp, and this slope will give us instantaneous rate of a reaction. Okay, so our instantaneous is plus dp by dt. Okay, dp dy by dx. Okay, simply that. So this is slope of the curve of concentration of products versus time graph. Okay, okay, so yeah, now what are the units of rate of a reaction? यूनिट्स क्या होंगी बच्चों रेट ऑफ रिएक्शन की? इट्स सिंपल, change in rate of a reaction is change in concentration of reactants or products over time. So concentration's unit is mole per liter and per time is second words. Okay, so mole per liter per second. Okay, so our average rate of reaction is minus delta R by delta T, we have seen, upon delta T, and it's also equal to plus delta P by delta T. Okay, now what is, we have seen the instantaneous rate of a reaction in the graphs. Okay, in these graphs. Okay, now what is it? Instantaneous rate of a reaction. Instantaneous rate of a reaction. Okay, it's the rate measured at a particular instant of time. Okay, are instantaneous, okay, at time at t equal to, as sorry, just a second बच्चों, yeah, as delta t tends to 0, okay, r instantaneous is given by minus delta dr by dt, okay, and it's also given by plus dp by dt, okay. This is the change in concentration of reactants upon change in time. Negative sign denotes that the concentration of reactant is decreasing over time, and this is rate instantaneous, okay. Instantaneous rate is given by this formula, okay, and it's also given by this expression. Plus sign denotes the change that the concentration of products is increasing over time. So dp change in plus dp change in concentration of products over time, over change in time dt, okay. Dt is the small time interval, so rate instant, it's the instantaneous rate, that is rate at a particular instant of time, okay. Now let's see a reaction. 2a plus 2a gives 3b plus 4c, okay. At t equal to 0, let its a concentration of initial concentration of a be a naught, or time t पे, let's say it's a naught minus 2x, okay, यानी कि 2x मोल्स इसके इनमें कन्वर्ट हो चुके हैं प्रोडक्ट्स में, 2x क्वांटिटी यूज हो चुकी है रिएक्टेंट्स की प्रोडक्ट्स बनाने में, ओके, एट टाइम t तक. So we'll get 3x concentration of B at time t and 4x concentration of C at time t. How we have got this? 2 gives 4, so here 2x has gone from A, so since it's giving double, from 2A we get 4C. So if 2x is gone from A, we get double quantity of C, that is 2x double is 4x, and 2 gives 3, 2a gives 3b, so 1a will, it's a simply unitary method, 1a will give 3b by 2, okay. So 2xa will give, as it's getting used 2x quantity of a, okay, it will give 2x into 3 by 2b, so let me write 2x into 3 by 2 of b, okay. So 2 will cut by 2, so we get 3x of b, okay. So 3x. Now therefore rate of disappearance, okay, first disappearance of product reactants, rate of disappearance of A RA, which is written like this, is given by minus D, as minus sign is because, now we all know that minus sign is because the concentration of reactants here is A is decreasing over time, so okay, so minus dA by dt, okay. So minus dA is 2x is being used, so 2x is the change in the concentration of A, okay. So 2x upon, and time taken is 0 to t, so dt is change in time, infinitely small change in time, which is t, okay. So 2x by t. Similarly RB is given by plus dB by dt, as this product here B is being formed So its concentration is increasing over time. So plus sign denotes that. Okay, so plus dB by dt. Okay, so dB is, it's 0 here and 0. So change in concentration of B is 3x over time, over infinitely small time interval 0 to t. So change in time d, infinitely small time interval dt is t. So 3x by t. Okay, similarly we can get RC also, and RC is equal to plus dc by dt. Okay, so dc is 4x and dt is t. Okay, so 4x by t. Okay, therefore rate of reaction, this reaction, इसका रेट कैसे पता चलेगा बच्चों? तो रेट पता चलेगा, therefore rate of reaction is equal to minus, will take rate of disappearance of A, okay, or rate of appearance of B or rate of appearance of C. ये ऐसे पता चलता है. Okay, therefore rate of reaction is equal to minus, will take 2 down. Okay, so x by t, it will become, will take 4 down, it will become x by t. Okay, and we'll take here, we'll take 3 down, so we'll get x by t. So these all will become, Ra will become equal to Rb equal to Rc, because they all are equal to x, will be equal to x by t. Okay, after rearrangements in these three equations, this one, and this one. Okay, so if we take 2 down, so we get rate of reaction is equal to minus 1 by 2 d A by dt. Okay, also it's equal to Rb, which is plus 1 by 3 dB by dt. Because we are, why we are taking these numbers down? Because rate of a reaction R is equal to Ra equal to Rb equal to Rc. So Ra equal to Rb equal to Rc will, Ra will become equal to Rb equal, will become equal to Rc only when they all equal. Okay, so x by t, x, so we'll make x by t, x by t and x by t, so they will become equal. Okay, so plus 1 by 3 dB by dt. Okay, this is rate of reaction R. This is Ra, this is Rb. Okay, dB by dt plus 1 by 4 dc by dt. dc by dt. This is Rc. Okay, so this is the rate of the reaction. All right. Now let's consider another example. N2 plus 3H2 gives 2NH3 ammonia. Okay, नाइट्रोजन और हाइड्रोजन मिलके देती हैं अमोनिया. ओके, देयरफॉर रेट ऑफ रिएक्शन, so what is the rate of reaction? This rate is given by minus d n2 by dt. Okay, or it can be, it is also given by minus 1 by 3. Minus sign is because reactant is, concentration of reactant is decreasing over time, and we have divided it by its stoichiometric coefficient. Okay, minus 1 by 3 d h2 by dt. Okay, it's also given by plus 1 by 2 d nh3 by dt. Okay, now let's consider another example. 5 Br bromine ions bromide ions, plus BrO3 minus aqueous plus 6H positive aqueous. Okay, in aqueous medium this reaction is occurring, this means. Okay, so 3, it gives 3Br2 aqueous plus 3H2O liquid. Okay, therefore rate of reaction is minus 1 by 5 dBr minus Br negative ions upon dt. It's also equal to plus, sorry plus नहीं माइनस आएगा, माइनस डी BrO3 minus upon dt. Okay, and it's also rate of reaction is also given by plus or minus, yeah, minus will come. Okay, just second bachcho, yeah, minus 1 by 6 d H positive by dt. Okay, and the rate of reaction can also be given in terms of products also. So plus 1 by 3 dBr2 by dt, or plus 1 by 3 d H2O by dt. Okay, by 3 dH2O by dt. Okay, एक सेकेंड बच्चों. Okay, now let's move ahead. Now we have studied about what is the rate of a reaction, what is the average rate of a reaction, what is the instantaneous rate of a reaction. Now let's solve one question. Let's start. For the reaction For the reaction, 3A gives product. Okay, this is the given reaction in the question. Variation of concentration of reactant with time. Concentration of reactant, variation of concentration of reactant with time is given as Ca. This is the concentration of reactant A. Okay, it's given with it is given, its variation is given with time. Okay, so it's given as 25 minus 3t minus 4.5 t square. Okay, so calculate initial rate R0, that is that. Now so calculate initial rate of reaction. Second, at time t2, sorry, at time 2, okay, at equal to 2, calculate rate of reaction. Okay, and third part of this question, calculate average rate between 1 to 2 seconds. Okay, solve this question. Pause the video for the moment and try to solve this question before moving on to the solution. Okay बच्चों, so yeah बच्चों, let's start its solution. 3a gives product. This is the chemical reaction which is given in the equation, which is chemical equation which is given in the question. Okay, gives product. Now first part. What is the first part? Calculate initial rate of reaction. First, let's write down this equation. Okay, variation of concentration of reactant with respect to time. Okay, so Ca, just a second बच्चों. So Ca is 25 minus 3t minus 4.5 t square. 25 minus 3t minus 4.5 t square. Okay. Okay बच्चों. Now first question. Sorry, I mean first part. Okay. So calculate initial rate of reaction. Initial rate of reaction is given by minus 1 by 3 dA by dt. Okay, minus sign denotes that the concentration of reactant is decreasing over time, so minus sign. Okay, minus dA, change in concentration of reactant A with respect to change in time interval, small time interval dt, which is denoted by dt. Okay, so and we divide this by the stoichiometric coefficient of A. Okay, so minus 1 by 3 dA by dt is the rate of reaction. Okay, so minus 1 by 3 dA, this is the concentration of A. So we just have to find the derivative of this equation. Okay, so d 25 minus 3t minus 4.5 t square upon dt. Okay, minus 1 by 3, this is constant, so its derivative is 0, minus 3, t is minus 3, and minus 4.5 t square derivative is 2 will come, t square derivative is 2t, so 4.5 into 2 is 9, so minus 9t. Okay, and we have derivated it with respect to dt, so this will only come. Okay, so at just a second बच्चों, at t equal to 0, because we have to find the initial rate. Okay, this denotes the initial rate for initial rate okay, of the reaction. So for the initial rate of the reaction. Okay, so we just have to put the value of t here, which is 0. So minus 9 into 0 is 0. So this quantity will become 0. So minus 3 will be left. So minus 1 by 3 into minus 3. Minus minus will become plus, and 3 will go by 3. So we'll get 1. Okay, this is the answer of the first part of this question. Now let's move to the second part. We have to find calculate at t equal to 2, calculate rate of reaction. We have to find the rate of reaction at t equal to 2. Okay, at t equal to 2, rate of reaction is given by, we have seen, minus 1 by 3 dA by dt. Okay, concentration of reactant is given by this expression. Okay, so minus 1 by 3 d 25 minus 3t minus 4.5 t square. Okay, upon dt. So minus 1 by 3, so its derivative is minus 3 minus 9t. Okay, at t equal to 2, we have to find the rate of reaction. Okay, So we just have to put the value of t here. So minus 1 by 3 into minus 3 minus 9 2. 9 times 2. 9 2s are 18. So minus 18 minus 3 is minus 21. So minus 1 by 3 into minus 21. So minus minus is plus. So and 3 sevens are 21. So 7 is the answer. Okay, this is the rate of reaction. Okay, bachcho. Now let's move to the third part of this question. What we have to find in the third part? Average rate. Calculate average rate between 1 to 2 seconds. Okay, now we have to find the average rate. So concentration of A at t equal to 1 is, concentration is given by 25 minus 3t minus 4.5 t square. So we get 25 minus, we have to put the value of t here. So minus 3, 3 ones are is 3 minus 4.5. Okay, 1 square is 1, 4.5 into 1 is 4.5. So minus 4.5. Okay, so this will give us 4.5, 7.5 minus 7.5, 18, 17.5 this is. Okay, and concentration of A at t equal to 2 second is 25 minus 3 t minus 4.5 t square. So 25 minus 3, 2 into 2 minus 4.5, 2 ka square. So we'll get 25 minus 3 to the 6 minus 2 to the 4. So 9, 18. This is 18. Okay, 18 plus 6 is minus 18 minus 6 is minus 24. So 25 minus 24 is 1. Okay, so therefore required required average rate of reaction is minus 1 by 3. Okay, a delta A by delta T minus 1 by 3 A2 minus A1 by T, and delta T is 2. Just a second बच्चों, एक second. A2 is concentration of reactant A at time t equal to 2 seconds. Okay, and A1 is concentration of A at time t equal to 1 second. So 2 minus 1. Okay. Okay. So minus 1 by 3 is A2 is at t equal to 2 seconds is 1. We just have to put the values now here. It's just that simple. Minus A1 is the concentration of A at time t equal to 1, which is 17.5. So 1 minus 17.5 upon 2 minus 1 is 1. Okay. So this is minus 1 by 3 into minus 17.5 plus 1 is minus 16.5. Okay. So 3 5s are 15, 116, 3 5s are 15. Minus minus is plus, so 5.5, and its unit is mole per liter per second. Okay, in the above parts also we can write this is the rate. We have calculated the rate of reaction in all these questions parts. So this is 1 mole per liter per second. Okay, and here also second part 7 mole per liter per second. Okay, this is the unit of rate of reaction. Okay, yeah, that's all for this video बच्चों. I hope आप सभी को ये वीडियो अच्छी लगी होगी. तो तो इसे लाइक और शेयर करना ना भूलें और ऐसी ढेर सारी वीडियोस के लिए चैनल को सब्सक्राइब ज़रूर करें। हम आपसे अब मिलेंगे अगली वीडियो में। तब तक के लिए स्वस्थ रहें, तंदुरुस्त रहें और पढ़ाई में जी तोड़ मेहनत करें। थैंक यू।